Hello, welcome to another Technical Corner. We're here with Rodney again from Langley Alloys. And Rodney, we're talking about today a really fascinating material. You've been developed this a long time ago. It's quite an old material.
For me, it's one of the oldest alloys in our portfolio, but it's one of the coolest as well. You look at some of the literature and it belies its age. You know,
Very retro.
This has been around from the 40s and 50s. It's right back to the early days of Langley Alloys, developing novel alloys for really challenging applications. In those days, it was naval. So copper-based alloys are really good for long-term seawater immersion.
Exposure.
Exactly. You know, they've got excellent resistance to corrosion, but they're not particularly high strength. So Hiduron was all about pushing the strength up of a copper-based alloy, and for many, many, many years, it was as strong as it got in terms of copper-based alloys. So you know, this sort of component is a model component dating back many, many, many years of a component from a submarine, a propulsion blade. But that would have been the sort of common applications through the 40s, 50s, 60s. That sort of naval hardware equipment architecture.
Yeah, you can imagine building big ships that are sat in the water for a long time. You see people scraping off barnacles and stuff on the little ships, but this helps to reduce that.
One of the sort of inherent advantages of copper is it resists that sort of biological growth. So in a naval or a subsea application, you're not going to get that build-up of algae and barnacles or whatever on the surface of the alloy. If you wanted to think of it a different way, if you see copper flashing on the roof of a house, you will not see moss and lichen growing on that flashing. The copper just inherently resists that growth.
Brilliant. And so how did you achieve the highest strength? What's it actually made of?
So it's 85%-ish copper. So that gives you that sort of resistance to seawater and the resistance to fouling. But to push the strength up, you put some nickel in there. So and a little bit of tin. So it's effectively a bronze alloy. But then there are additional, very small additions in there that will form precipitates, and through the production process help to age harden, to strengthen the alloy. And it's really cool because it will just achieve that strength almost irrespective of the diameter of the bar, the section thickness of the component.
And even though it's an older material, it's actually had a bit of a renaissance in recent times just due to its ridiculously high strength and being best of the best for such a long time.
It's one of those products that's found its time, I guess. You know, originally it was all about naval applications, and that's what it was developed for. But it's got this cool combination of mechanical and physical properties that make it perfectly suited to subsea components. These days, there's all sorts of kit and equipment sitting at the bottom of the ocean, operating and controlling various parts of oil wells. And it needs strength, it needs corrosion resistance, sure, but what it also benefits from is that non-fouling, that resistance to sort of build-up of algae and barnacles, but also galling as well. So galling is one of those phenomena that only a few people will come across, and it's where you will have metal components that have a tendency to sort of seize or stick if they've been held together under pressure for a long period. Making one part of the component out of Hiduron resists that sticking or freezing. So all of a sudden, things like couplings or connectors or stab plates, which are ways of making hydraulic and electrical connections underwater, can be facilitated by making parts of them out of Hiduron. You can connect them, you can leave them connected for long periods, and then you can come along and with complete confidence disconnect them, knowing that they're not going to gall, stick, freeze, just simply break apart.
Absolutely. It's fascinating. You've got these little rovers going down to the bottom of the sea trying to pull these connectors apart.
Like I say, you've got pumps and valves and wellheads and all sorts of equipment, you know, on the floor of the ocean. It's in deep water, it's offshore, it's not in particularly accessible locations. And the fact that you can use an ROV, a sort of submersible vehicle, to go down and actually connect and disconnect as you move equipment around really just changes the way that these I guess offshore operations are run. You know, you're not reliant on sending divers and people and equipment down there.
And obviously Langley Alloys being the originator of this material a long time ago, you're the stockist to go to for the material.
I hope so.
Yeah, I hope so too.
When we're talking about couplings and connectors, that is smaller diameter bars, so they're very readily available from stock, but it's also used in valve trim and other components, so we'll carry stock up to 8 inches, but occasionally we will have a customer asking for some really big blocks, some big pieces, and at that size you're talking about having them forged to order, you know, bespoke forgings. But metallurgically speaking, this alloy achieves its strength irrespective of the section size, so the only limit really is the application rather than the metal.
Brilliant. So one of the strongest copper-based alloys, invented Langley Alloys and supplied by Langley Alloys from, I mean, up to the sizes that you want in forgings that you need direct from the mill or in standard part sizes.